Oh, good afternoon. Hello, good afternoon. This is Professor Khan. Welcome to the class. This is week 5, Advanced Heat System Design, and in this week we will discuss auxiliary heating loads. By auxiliary, we mean stuff that require to have some heat, but they are not base of the. It's not there to heat the house, like heating a spa, appliances, pool, indoor pool, outside pool, or domestic hot water for showering and inside stuff. So by now this is week 5, and we did heat load calculation, sources of heat, so you have an idea of how to use your heat stuff. And probably you'll be asked to consult in some matters to, okay, how much does it cost to heat this pool or heat this spa or install a jacuzzi, what have you? Should I get a heat pump? Should I get a gas? So now probably you have enough information to answer any of these questions. Okay, let's move on. As you can see here, I put my notepad with the pens in case we need to do some calculation. I think it's better to do it on the page instead of doing it with my finger on the screen. So let's see how that goes. And I'll try to keep this video around between like 15 to 20 minutes and chunk it up to smaller videos. Okay, moving on. Let's go further. Okay, hot water on demand. Plus, you'll be able to quantify the heating water requirement and conditions, how much is required to heat for hot water uh, for residential purposes like showering, cleaning, and so on. We'll identify the types of water heaters and rating, what is available in the markets, how are they rated, why do we need to know that, what are our options, and what are the pros and cons for each one of those. We can estimate also the domestic hot water requirement, and if we are going to be using hot water system, meaning if we're going to be using uh, hot water to heat like radiators, maybe we should just use that system to heat our domestic hot water since we're doing hot water already. Why duplicate and do another system? So you can see probably a lot of boilers now. They have domestic hot water coil and also the heat water for the house. So that's another possibility. We can also calculate the swimming pool heating loads requirement if you want to install a swimming pool in a cold area, even in a warm area like Florida or so. Probably you would need to heat the water at some point. So it's good to know how to estimate that heating load. And even if you are not planning to work with that, it's good to have the information and know where to look for it if you need to find it. We'll also determine the required additional boiler capacity for domestic hot water or for a spa or a jacuzzi. Okay. And by the way, jacuzzi is just a hot tub, but jacuzzi was, I think, is a brand name. I just learned that recently. Okay, so hot water requirement and conditions. We want to know what are the high and low limits, and the high limit is done to prevent scalding. It's really easy to scald yourself with hot water if you're not paying attention. And now they have some kind of anti-scalding device. Anything above 120 degrees and 240 is going to cause scalding and sometimes permanent damage, depending on your temperature on your skin conditions. If you have water storage around 110 degrees or below 110 degrees to like 90 degrees, that will cause a lot of bacterial growth, which is not good because now you are promoting a harmful bacterial growth in your water tank that you might use for cooking or drinking. That's a good idea. Scalding is very damaging again, and there are some thermostatic valves that prevent you from having scalding. So they will manage the hot water dispensing from the boiler. And so it's kind of like a pickle because you have to store the water at a certain temperature, like high at 140, but you don't need it to be this high. So you got it's a little bit heating water more than you need to, but it is required if you're going to store water to heat it at that temperature for the bacterial growth, and also you don't want to dispense that water to cause scalding. So we said probably you can find it in the book between 120 140 is the optimum storing temperature, and you don't want to go below 110. What is the comfortable water temperature? Wash your hand or shower, probably 85 or 80. That is considered comfortable water temperature. What is the temperature of most swimming pools? So usually it's 80 degrees for swimming pools. That's what we find comfortable. And if you go below, probably if you are doing Olympic pool where the people are doing a lot of activities, probably 78 is more comfortable because people will be doing a lot of movement. Okay, moving on. Gas-fired water heaters, those are very common and they use, as you can see here, let me get my markers. Hold on. Where are the markers? Okay, is that coming? Okay, never mind. I got it. I got it. Yes. So if you look, you are basically storing the water in this region over here, and you have a small little boiler or a gas a burner that heat the water from the bottom, of course, and you have all the combustion air coming to the outside. However, you might also have you need air to come combustion air coming to the inside with the gas, and that will be dispensed outside. And some of those are sealed, some of them are uh, open, meaning they either pull air from the outside, from the store, from the garage or basement that you have it in, or some of them pull the air from the outside. So you might have a specific opening in the house that pull in air and take out air as well at the same time. All hot water system require to have a relief valve. This relief valve is usually rated at 30 psi. We're gonna write it down here. 30 psi. Another piece of information, 30 psi or around that for any relief valve. That to prevent uh, a pressure buildup, and those relief valves are tagged and tested probably every 2 years, and there's an expiration date on those valves. It should be attached to it. Thermostat to control the in and out, I mean the temperature, and to maintain the temperature in there. And probably if you work with aquastat, you know the aquastat maintain the temperature of the water between two limits, low and high. The drain is very important, and that's where you drain all the sludge and the rust that accumulated in the bottom. It is, if you look at it, it's a little bit gross because it's a combination of rust and bacterial growth, and sometimes uh, whatever comes with the water and precipitate in this area and accumulate. So you want to drain that. Also, you'll have something called the anode rod. This is the anode rod is a sacrificial piece of metal that rust before the tank. They are to be replaced every 2 years or so. And once you have deteriorated all this anode rod, the tank will start eating itself and deteriorate. So we said again, there are ions in the waters, and those ions get more activated with heat, so it will eat itself eventually and rust faster than cold water. So anyway, this rust will accumulate in some kind of small little particles, and every maintenance by depending on what is recommended by the manufacturer has to be drained and replaced, have to be drained and flushed to the outside. That's why we have a drain here, and it's very required to have a drain, and it's where the cold water inlet comes in. There's a lot. We did spend the whole week talking about water tanks, so that was like an EST-204 heat system design, and probably all of you took that. So please go and review that. If you need some more information, let me know. So moving on. This is the gas water heater. Indirect water heaters, those use the hot water coming from the boiler. So you already have a boiler for hot water system over here, and you use indirect water here. You have a coil or a loop coming, like you're borrowing heat from this boiler. There's a coil in here to absorb heat and take it to this boiler and comes back in. So we are taking some heat from the boiler, as we said, to heat our domestic hot water. The advantages, we do not have mixing of water, the water that is used for heating the house with the water that been used for domestic hot water system. And I'm comparing it to a direct water heater where you use the water inside the system. So this water is mixed up with whatever inside the boiler. That's not really, I mean, I've seen it, but it's not very common. And again, you can use antifreeze if you want to for heating the house and leave the hot water intact. But again, that is not recommended in case there's a leak. small leak, it could be problematic with using cooking water for antifreeze, which can be very toxic. One boiler is used to heat the house and heat domestic hot water, so that's a little bit also a good idea, but can work against you in the summertime because you have to turn on your boiler even though it's summertime. No need for heat source for domestic hot water. I mean, independent heat source. And these tanks are a little bit cheaper usually than other tanks with their own heat source. Disadvantages: the boiler can run even if there is no need for heat, which is costly, and the boiler is oversized to cover the heat demand. Not all the time, depending how much hot water demand you have. For a small house like single family home, it's okay because the water demand is not that high, and you already have increased your boiler size by 15%. If you remember, we did add 15% already to the boiler because for cold startup, and so it's possible to use that 15% to heat the the water, and also it's good to use that water heater from the boiler. Uh, because if you think about it, most of the hot water is being used in the morning. Everybody showers, everybody's trying to get out of the house, and by that time you turn off the heat. So you go turn off the inside of the house heat and use the hot water. So the boiler is still working to supplement for the hot water demand, and at the same time you are not really exhausting the energy for heating the water and also using the heat for the house. I hope this makes sense a little bit. So direct and indirect is the comparison between direct water tank and indirect water tank. Again, the direct water tank has some advantages that we will use the water for showering or what have you, and in the indirect water tank you are borrowing some heat from the boiler. So they both have different installation. Of course, this is much cheaper because you're using the water the the system, inside the loop. And in this system, if you have guests, you will need to have some makeup water coming inside, and probably you have a makeup system to keep the water level inside the boiler, inside the system, uh, constant. Okay, moving on. Another ways to heat houses is in tankless water heaters or on-demand water heater. These are amazing because they do provide us with hot water on demand. We have a very efficient heat exchanger here that will supply you with hot water as soon as you turn on the faucet. So you turn on the faucet, you do not have to wait too long because the pipe is very short. And probably you have noticed you turn on the heat inside a house and you have to wait for the water to clear. Let's say you have 3-story house and this is your boiler and the faucet is in here. This is the sink, and you have your faucet over here and you want some water. You open the water, so all the water coming from the pipe all the way to here has to clear out, and probably we have here at 140, and probably here it's going to be 60, 70, and so you have to pull all this water which is wasted until you get the right temperature water. So this actually cuts that distance and save you a lot of energy. Okay, and these are also used very commonly for heating a house. If you have a small hot water system or small apartment, you can use on-demand gas water heaters to heat your house instead of using a big boiler in the basement. Advantage: no need for hot water storage tank. You need to store tank. That's really great because whenever you store water, you're gonna lose energy, right? And the hot water is supplied on demand, and it has lower operating cost because again it uses gas. They do not use oil. I have not seen successful on demand oil uh, water heaters, and they used to be for small size occupancy, but now they have more efficient and more reliable uh, on-demand gas water heaters. Disadvantages, of course, you can think of more advantages and disadvantages, what I can come up with. Some of the disadvantages, in some cases, it can be very low capacity, but again, that depends. Repair requires separate piping scheme. So it's if you are going to install that in your bathroom right now as a retrofit, probably you need to do a repiping of that bathroom. So because this technology, they only came maybe in the last 5 or 10 years. So if you have a house that's built in the 60s up to the 90s, probably you do not have any of these water heaters, and you are required to do some kind of new piping. It requires direct venting to the outside, so it has to be a sealed construction where you go inside and outside the 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 building. Okay, so ratings. How do we rate those boilers? There's something called the first hour rating, which basically how much hot water can this boiler supply you in 1 hour. You can read the definition. It's a little bit complicated, but that's an old rating. Now we do the GPM, continuous GPM. That's what we find more common now in the market, or sometimes it's liter per second, or whatever kind of unit you have. But if you think about it, you can have a small indirect water heater that give you 1 gallon per minute. That's my capacity. And you're gonna get, I'll guarantee you to have 1 gallon per minute at 90 degrees continuously. So that's the rating that now you can find a lot of those water heaters, how much it can supply you. There's a lot of physics that goes into water heating, and especially when you store the water. I'll talk about it a little bit. So I'll give you an example, just to give an idea of what's happening, and probably you've thought about that already. So if you have a tank, a hot water tank, and the water coming into it is from the town water or the municipality water, it's coming at 50 degrees. I hope you can see that 50 degrees, okay? And the water inside here is already been heated to 140 degrees. And let's say you are pulling water from here and mixing it with city water to get flow rate. So you're gonna get 140 degrees, and you mix that with 50 to get, probably you have a regulating valve to get around 90 or 100. So what happens here for the water is this water will get spent. So the first few minutes you'll get 140, then this water will mix inside 50 and 40, and depending on how fast this tank empties, you're gonna get an average of 140 plus 50 over 2, so you'll get 190 over 2, so, and that will give you around what is it, 90, 80, that's 95 degrees total, which is, again, it's not that bad. However, at the same time, you are either heating this water using electrical, gas, or whatever. So how much heat you put in and how much water it's coming in there. So there's a big calculation to tell you how much of constant hot water can you get going further. And the efficiency of the heater versus the cold water coming inside depends how much you can get from that boiler. I hope this makes a lot of sense, but it's good to think about it this way. And where you install the boiler makes a difference, because again, we are counting a lot on the incoming water. Okay, how much is needed? These actually are information that I pulled from the Department of Energy. Clothes washing, showers around 10 gallons. That's being conservative. You can go less than that depending on the shower head you have. Automatic dishwashers, they take around 6 gallons of water, and actually they are more efficient than just washing dishes by hand. Because again, they do it in bulk, and it uses less water than you having the faucet going all the time. Kitchen faucet flow is like 2 gallons per minute. So probably you can think about how much you used washing dishes instead of using the dishwasher. Bathroom faucet, again, is going to be the same thing. And on daily average, you will use 64 gallons of hot water. I'm talking about hot water in general, mixed and ready for you to use. So this sheet is available in the book to calculate per person. So this is again on the conservative side, and some of them can be eliminated in terms of shaving or hand washing. You can kind of tweak that a little bit, but this is just kind of a general rule, and you can multiply that by person to know how much you are using for that house. Okay, I'll pause now and start the other video, and we will discuss pools and spas.